Yes guys, welcome back to NEET World. So we are discussing on quantum numbers, right? So in the last session we have discussed the theoretical part regarding quantum mechanical model and also quantum numbers. How these quantum numbers are like extracted from Schrodinger wave equation also we have discussed right now. So we have two parts, one is radial part, angular part, where radial part gives principal quantum number and azimuthal quantum number, n and l values from radial part of Schrodinger wave equation, and also then we discussed the angular part which gives again l value and ml value, azimuthal quantum number and magnetic quantum numbers are comes from angular part. These are the three quantum numbers obtained or extracted from Schrodinger wave equation right now. So then later one more new quantum number added, that is spin quantum number. All together these four quantum numbers give us the complete information about finding an electron in an atom. Right now this is what we discussed in the last session. Now let us do few questions related to these quantum numbers from JEE and NEET exams. See, we have a question from JEE 2024. The question says the four quantum numbers for the electrons in the outermost orbitals of potassium is R. So how do we identify this? How do we identify this? See, you can write the electronic configuration of potassium. So you will be getting around like something like the last electron, they are saying outermost orbital of potassium. So what is the outermost orbital of potassium? 4s1. Right now it means we need to give the quantum numbers that are associated with this last electron, this 4s1 electron. Okay, so now very simple. So tell me, what are the quantum numbers for this electron? What are the quantum numbers associated with that electron? Tell me. See, here we have one electron which is present in this shell. What is the shell number given? N equals to 4. Take it as 4. Principal quantum number is 4. Since it is s orbital, so what are the angular momentum? What is the subshell numbers I have discussed? So for s orbital, L is equals to 0, you can say it is s orbital. If L equals to 1, it is p orbital. Okay, so the subshell number will be fixed. For a particular subshell, the L value will be fixed. If s subshell is there, its L value will be 0, and p subshell is there, its L value will be 1. For d subshell, the L value will be 2. For f subshell, L value will be 3. Something like this. Their L values are fixed. Okay, for each of these subshell. So since s subshell, its L value will be 0. Hope it is clear up to here. Now what are the other things? See, next, what about ml values? Ml values lies from plus L to minus, plus L to 0 and minus L. Right now plus L to minus L it is. Plus L to minus L. See, since L value is 0, I can only have ml value as 0. Hope this is also clear. So now what about the spin of this electron? Only one electron is there now, so it will be either having plus half spin or minus half spin. Okay, so n equals to 4, and L equals to 0, and ml azimuth magnetic quantum number is also 0. So see this kind of options. See, 4 0 0. Okay, is there any other one? Yes, this is clearly our answer. We have 4 0 0 and spin value is half. So ms is half. Okay, so option B will be the exact answer for this question. Hope this is clear. Yes, if it is clear, tell me in the chat box it is clear. Or you can just click on the like button so that I can understood that you are following the session very seriously. Yes. Now one more question I am asking you as a homework. Now tell me, what are the four quantum numbers associated with the last electron of sodium? The last electron of sodium. What is the last electron of sodium? Write its electronic configuration. You will be getting something like 3s1. This is the last electron of sodium. Just tell me what are the quantum numbers for that. And also one more question I am asking, what are the quantum numbers associated with the last electron of chlorine? What is the last electron in the chlorine? So just write its electronic configuration. That last electron is present in p orbital now. Try to get it and tell me in the chat box. I will be looking into your answer here. Okay, feel free to express your answers. Even it is wrong, I will make it correct in the chat box and I will make you feel comfortable with the like discussion. Okay, so here you need to just think about your learning process, not about what others think if you say wrong answers. Okay, yes, let us continue the session here. See, we have this many questions in quantum numbers, and we have very lot of questions because quantum number is one of the very important topic that should be understood by every aspirant. Okay, compare the energies of following set of 4 quantum numbers for multi-electron system. See, they have considered, they have specially mentioned multi-electron system. Since multi-electron system contains more than one electron, now it means you have to consider, see, if this is a nucleus, these are the shells, let us say. Okay, so now we know electrons are present in inner orbitals and outer orbitals also now. So now between this nucleus and electron there will be attractive forces. Right now between electron repulsive forces are there. Okay, so considering both of these, we need to take n plus L value. What is that? We need to take n plus L value while calculating the energy of multi-electron system. If n plus L value is greater is its energy. Greater n plus L value, more energy it has. More is the energy of that particular electron. Okay, and next one is, if n plus L value is same, so you just consider higher the n value, greater is its energy. Greater is its energy. Now based on these two statements, just tell me, here n value is given 4 and L value is 1. So total n plus L value 4 plus 1, 5 for this, and for this n plus L value 4 plus 2, 6. Okay, and what about this? N plus L value is 4 only. 4 plus 0 means 4. Here 3 plus 2, 5. Okay, so based on this, where do we have highest energy, highest n plus L values for B? So take it as B first. After this you tell me, after this, so after this what we have? Here 5, here 5, here 5. So both of them have same n plus L value. What I told in this case, greater the n value, greater is its energy. See, greater n value over here, so that A should be here. Okay, after that D, and least is E. Least is, see here we have something like C option also. See, what about C value? C is also having 4. C is also having 4. Okay, so now B, A, so B is 6, and then next this is 5, but more greater n value, so greater is its energy. After that D, and between C and E, here we have 4 and 4, but n value is greater in E case, so write E here, and least is C. So just check the option which is having this kind of order. So just check where do we have this kind of option. B, A, and C here is 4. Okay, and yes, just check n plus L values once again. Just check once again. See, here n plus L value is how much? N plus L value is 5 in the first case. In second case it is 6. In third case it is 3 plus 1, 4, and here also 4, but you know greater n value here, so it will be having more than this C, and here it is 5. Okay, just based on this, B is greater. After B we have 5 here, so A I am taking, and after this D. Okay, write like this, BAD. Okay, BAD, where do we have BAD? Yes, here we have option number 4 as an answer. Okay, so just be clear with your concepts, then that will be definitely gives you the perfect answer. Even sometimes even options may not be correct, but if you are clear with your concept, just believe in that, you will definitely get the correct answer. Right now? Yes. Yes. So I hope it is clear why I am taking BAD as a high order like this, because greater n plus L value, greater is its energy. And after this you can check, so both of them have same n value, same n plus L, but greater n value, greater is its energy. So here E and least is C. So we have least is C in the fourth case, that will be your answer. Okay, and next option, next question here we have, arrange the following orbitals in the decreasing order of energy. Same, just follow the same trend that we have discussed in the last question. Just take n plus L values. See, n plus L value is 3 here, in this case it is 4, in this case it is also 4, in this case it is 5. So greatest energy is for D, highest energy is for D. After that C, B are having same n plus L values, but you know n value is greater here, so write B here. And next C, and the least is for A. So where do we have D, B, C, A? Yes, option B you will be correct answer as this order is followed there. Hope this is also clear, right? This is also clear. I hope voice is clear now. Everyone in the chat box tell me voice is clear or not. Yes, okay, yeah, let me continue further. What about this? The quantum numbers 4 of 4 electrons given below. Yes, these are the quantum numbers given for 4 different electrons. Okay, so now tell me which is having highest energy. See, same topic, I mean same formula or same concept, I am discussing this for the third question also. What are the rules I told you in for finding energy order? Just take n plus L value rule first, and later considering after this if n plus L values are same, take only n value. Okay, greater the values, greater is its energy. See, n value and L value, here it is 5 and here it is also 5, here it is also 5 and here it is also, here it is 4. So greater value in which case? See, here in the first case it is 6, 4 plus 2 6. Okay, so one is having greatest energy, one is highest energy, and after this n, here what is n? So n is principal quantum number. If you haven't seen the last live session just half an hour before, I have made a special video on quantum numbers, so you can watch it. Okay, those who are asking in the chat box. Yes, so first find n plus L value, sum of them is 6, so greater n plus L, it will be having highest energy 1. After this, out of these 2, greater n value here, so 3. After this you can say 2, and least is for 4. So where do we have this kind of answer? See, 1 3 2 4. Yes, this will be the perfect answer. Yeah, okay. Next, here one more question for you. Just try to look at that question. Yes. So yes, the quantum numbers you can also start. You have been also studied in 10th standard even, because you need to learn electronic configuration, writing of electronic configuration now. So there it will be very useful. Without knowing this, you can't able to write the electronic configuration. Okay. So now tell me which are the following orbitals do not exist out of these 3s. Out of this 3s, 3f, 2d and 1f. So tell me, how can we say whether these orbitals, when a orbital is exist or not? So just take its n value first. If there is some particular n value, our L value should be always less than n. Okay, so it can from 0 to so on n minus 1. L value varies from 0 to n minus 1. It should not be equals to n. L should not be equals to n, or L should not be greater than n. Okay, always L should be less than n only. Okay, this is the rule you should remember. Okay, so based on this you can answer this question. So what is the n value for 3s? See, n is given as 3. So L has to be 0, 1, 2 only. It should be 0 to n minus 1. Since n is 3 minus 1, so it will be up to 2 only. 0, 1, 2 only. These are the possible L values. Okay, so if it is 0, I can say that is s orbital. Okay, if it is p, I can say p orbital. If it is 2, I can say d orbital. See, therefore for 3, s orbital is possible, 3s is possible. Since its L value can be having 0, so 3s is possible. So this exists. Okay, when it comes to the f, so tell me, n value is given as 3, but for f, what is the L value? See, for L 0 means it is s, L1 means p, L2 d, L3 f. Right now, see, n is 3, for f orbital L is 3. See what I told you, L and N should not be equal. Right now L always less than the N, then only it is exist. So here 3F do not exist here. Why? Because L and N should not be equal. This should not be equal. Okay, L always less than N, you should remember that based on these 3 statements. Okay, now what about 2D? See, N is 2, again N is 2 here, and for d orbital what is its L value? It is also 2. So N and L are equal, so this is also will not be possible. Okay, remove that. Okay, now what about this 1F? So N value is given as 1, and for F orbital L is 3. See, L subshell number, this L Azimuthal quantum number is exceeding the principal quantum number. This is also does not exist. Right now, see, this is also not a correct rule. Only this will be the correct rule that should be followed. Okay, that's why. So 3F, 2D, 1F does not exist. Only 3S is exist. Okay, these are the 3 orbitals which are not existing here. Hope this is clear. Hope this is clear. Yes. Okay. Next, what about this? Just try this question based on, from the NEET paper. I have collected this. Just give a try. What is the only thing you need to consider? Just consider N plus L or N. First consider this, later this. Okay, use these 2 and tell me. Use these 2 things and tell me. So tell me here. So we have 4D, 5F, 5P like this now. So arrange them based on their decreasing order. See, for 4D, they have mentioned, N value here is 4. What about D, L value? D will be having 2, right? Right. Okay. So total sum is N plus L is 6 for 4D. And for 5P, N is, for 5P, N is 5, and for P, L will be 1. So total sum will be 6. Okay, like this you just get the numbers of everything. N plus L rule you just apply. Okay, and the next one is what? 5F. N value is 5. For F orbital, L value will be 3. So it will be 8. Okay, and the next 6P we have now. N value is 6 given. For P, L is 1. So total sum will be 7. So based on this, tell me which is maximum number here. Maximum is for 8 for 5F. Okay, so 5F will be having maximum, 5F maximum energy, and the next 7 here. So 6P. Okay, and the next after this, look at these 2 numbers. These 2 numbers sum is same, but greater N value over here. So 5P should be having greater energy. Okay, 5P, then 4D. Okay, based on this, where do we have option 6P, 5P? So first option will be your perfect answer for this question. Okay, right now it is also clear, I hope. If it is clear, just click on the like button. Yes. Now next, this question is also from NEET. We have discussed about Bohr's atomic model. So tell me, which are the following transition spectrum of hydrogen atom falls in visible region? Yes, tell me which in hydrogen atom spectrum, where what is the series of lines comes in visible region? So it is Balmer series. Whereas Lyman series lines appears in UV, this appears in visible, and remaining appears in IR. Right now? Yes. If you haven't watched this, just go through the yesterday's session. Yesterday's live I have discussed about Bohr's atomic model. Okay. Next, here we have one more question based on quantum numbers in NEET 2024. So just match what about N value. So N gives principal quantum number, gives about size of the orbital or energy of the orbital. Right now they mentioned size of the orbital, so I matched with 2. Like that, you tell me try to match them. See, and the next here L is there. So L means what? Azimuthal quantum number or magnetic quantum number? It is azimuthal quantum number na, or angular quantum number that says about shape of the orbital. What is the shape of the orbital? L gives the shape of the orbital. If L is 0, we are saying S orbital, which is having spherical shape. Right now, if L is 1, we are saying P orbital having dumbbell shape, like that now. So L gives shape of the orbitals. Okay, next ML. What is this ML? So this is magnetic quantum number, says about orientation of orbital. Right now, orientation of orbital here. Okay, and MS means what? MS gives us orientation of electron, the spin of electron, whether it is having clockwise direction spin or anti-clockwise, plus half minus half we are saying now. So MS is 4. So based on this A3, so A3 here and B4 here, C1. So option number 3 will be your answer for this question. And you know, you just give a try for solving this question. If not, just check Bohr's atomic model in this channel itself. Just go through the playlist and check. So you will be having a special discussion on Bohr's model for solving this question. Or you can try. If not, then you can watch it. Definitely will get help from that particular video. Okay, if you want to learn completely about Bohr's model, you just go and search in the playlist. Golden Minute series will be there. There I have discussed Bohr's model in very few minutes. That will be helpful for you. Okay, next. And you know, if you wanted to join our Telegram group, just go to the description box where we have provided the link for Telegram channel. So just click on that. That will direct you to the Telegram group. There you can access the like lecture schedules and also the notes, and you can also discuss doubts in this channel. Okay, we will be also be there to guide you in the channel. Okay, so you can interact with the other teachers also in the channel. If you are really interested, just click on the link provided in the description box to join Telegram group. Okay, next here we have one more question. Yes, let me show you the one more question from JEE 2024. Just read this. So try to read this question. Consider the following statements. The principal quantum number n is a positive integer with values. So try to answer this question. Principal quantum number n is a positive integer with values n equals to 1, 2, 3, 4, so on. Right now, that is correct only. Okay, next. Azimuthal quantum number L for a given principal quantum number n. Values varies from where to where. L will be from 0 to so on n minus 1. It should not be equals to n. L should not be equals to n. It should be always, L should be always less than n. This is what we studied now. So, but they are saying 0 to n. So, it means option B is incorrect. Option 1 is correct. Okay, next. Magnetic orbital quantum number ml for a particular L has 2L plus 1 values S. That is correct only now. For example, L value 1 if I say, what are the ml values possible here? So we should take 2L plus 1. Okay, so this L value is 2L plus 1 we should take. Okay, so 2 into L value is 1 plus 1. So 3. ML values are 3, magnetic quantum number values are 3. What are those 3 values? From minus L to plus L, includes 0 also. It means minus L means minus 1, 0, plus 1. These are the 3 ML values. Okay, so this option C is also perfect statement, that is also correct. Okay, yes, I am looking into the chat box. Yeah. Yeah, tell me what about the next statement? D, option D here, plus and minus half are the two possible orientation of electron spin. Right now, so we can have, if clockwise direction, if you are indicating with plus half if you are indicating. For anti-clockwise direction you can indicate with minus half, or vice versa you can indicate. Therefore these are the only two possible spins. So this D is also perfect one. Okay, what about E? Options E you can look at here. For L equals to 5, for L equals to 5, okay, what there will be a total of 9 orbitals. Is that correct? No, I will say that is incorrect. Why it is incorrect? See here, total number of orbitals possible is 2L plus 1. Just now I discussed. Okay, so 2 into L is 5 plus 1. So total 11 orbitals are possible. Right now, so what are these 11 orbitals? You just think. L value 5 means it is G. Okay, see, for D it will be 2. For P you are saying 1, for F it is 3, G it is 4, for H it is 5. So L5 means it is a H subshell you can say. If there is something like H subshell existence, then it will be having how many orbitals? 11. Something like D orbital will be having 5 orbitals, and F subshell is having 7 orbitals, and then G will be having G subshell will be having 9 orbitals, and H subshell will be having 11 orbitals. So based on this, option is incorrect because they are saying just 9 orbitals. It is incorrect now. So what are the correct options out of this 4? A, C, D. A, C, D should be your answer. Hope this is clear. Yes, hope it is clear. If it is clear, just click on the like button once again. Yeah, let me move forward with one more question. Yes, look at here. Which are the following set of quantum numbers is not allowed? So tell me, which is not allowed? N equals to 3, L equals to 2. See, what is a basic of statement I have given? See, most of the questions are on this rule only. Either N plus L rule for finding energies, or based on this N value. Okay, this based on this two statement, greater should be the N plus L, or if it is same, follow greater N value, greater is its energy. Based on this rule, this is the one model question. And the next model question, see again, N value should not be equals to L. This should not be equal. Always N should be greater than L. This is another important model question that we are seeing most generally. Right now, look at here. See, N equals to 3, L can be 2. It is possible. Here also N equals to 3, L can be 2. This is also possible. Okay. See here, N equals to 3, L is also equals to 3. Is it possible? N and L should not be equal. So option 3 is not possible, or I can say not allowed. Right now? Right. Hope it is also clear. So option 3 is not allowed. You should choose option number 3 as your answer. Hope all the questions that we have discussed till now are clear, and if you wanted to cover any of the particular topic, just mention in the chat box. I will be discussing them in the upcoming sessions. Okay, and thank you for watching. Stay connected with this channel, and you can also share with your friends. If you haven't subscribed yet, just click on the subscribe button first. Okay, and thank you.